Hi everyone! Today's lesson is about solving systems of equations by graphing, substitution, and elimination. A system of linear equations is a set of two or more equations where the variables have the same unknown value. The solution of a system of linear equations in two variables is an ordered pair such as x comma y that satisfies both equations. There are three ways to solve a system of equations. The first method is graphing. The second method is substitution. And the third method is elimination. In order to solve a system of linear equations by graphing, let's follow these 4 steps. The first step is graph the first equation. The second step is graph the second equation on the same coordinate plane. Step 3 is determine whether the lines intersect, are parallel, or are the same. The first step is identify the solution to the system. If the lines intersect, identify the point of intersection. Check to make sure it is a solution to both equations. This is the solution to the system at the same time. If the lines parallel or if the lines are the same, we will look at these in different lesson. Let's start with one example. Our first equation is y equals x minus 3. The second equation is y is equal to negative x minus 1. Let's start with identifying our slope and y-intercept. For the first equation, which is y is equal to x minus 3, our slope is the coefficient of x, which is 1 over 1, and our y-intercept is 0, negative 3 in coordinate form, or you can also say negative 3. For the second equation, y is equal to negative x minus 1. The slope is negative 1 over 1, and the y-intercept is 0, negative 1. Now, let's graph them. Let's create the graph for each equation. I'm going to start from negative 3 for the first equation, which is negative 1, negative 2, negative 3 right here. So that's my start point. And I am going to go 1 unit up and 1 unit right. Rise over run, I am going to apply here. 1 unit up, 1 unit right will end up here. I will continue with this same pattern a few times to make sure that I have nice points that I can connect easily. So 1 unit up, 1 unit right. 1 unit up, 1 unit right. And I can do the same thing in an opposite way. 1 unit down and 1 unit left. 1 unit down and 1 unit left. If I connect these points, my line will look like this. Now I will do the same thing for the second equation. My first start step is -1, which is right here. Start from -1, and because it is -1/1, I'm going to go 1 unit down and 1 unit right. So I'm going to go 1 unit down and 1 unit right. 1 unit down, 1 unit right. 1 unit down, 1 unit right. If I continue with the same pattern on both sides to have a nice set of points where I can easily connect. Let's connect them. And when you look at these two lines, you will notice they intersected at this point here, which is our solution. So our solution is this point is 1 and -2. So our solution is 1, -2. Before I move on, I would like to check if I get it right. So I'm going to check my solution. I'm going to write the first equation, which is y is equal to x minus 3. And I'm going to plug in x and y values as 1 and -2 for the equation to see if both sides of the equation is the same. For y, I am going to plug in -2, and for x, I'm going to plug in 1, and I am checking if the both side of the equation is the same. -2 is equal to -2. So it worked for the first equation. Now let's check for the second equation. Y is equal to -x minus 1. And I'm going to plug in 2 for x, -2 for x. And negative comes from the original equation. And 1 for x minus 1, which is also, you need to check these, which is also correct. So -2 is equal to -2. It worked also for the second equation because it worked for the both equations. Then 1, -2, the coordinate or ordered pair, 1, -2 is the solution for this system. Now let's try another system. Our first equation is x plus y equals 0. I'm going to write this equation in slope-intercept form to find easily our slope and y-intercept. Just to recall what was slope-intercept form, it was y equals mx plus b. In order to isolate or in order to write y equals mx plus b, I have to subtract x from both sides, so y could be isolated. So from here, my slope is for the first equation, -1/1, and our y-intercept is 0. And for the second equation, which is already in the slope-intercept form, we can easily write down our slope and y-intercept. Our slope is -1/2, and our y-intercept is 0, 1. Now let's graph them. My start point is negative 0 for the first equation. And I'm going to go 1 unit down and 1 unit right. So 1 unit down and 1 unit right. 1 unit down, 1 unit right. 1 unit down, 1 unit right. And I'm going to do a few more points to make sure I have nice set of points to connect. Here we go. And let's do the same thing for the second equation. My start point is 1. I'm going to start from 1. And I am going to go 1 unit down and 2 units right. So 1 unit down and 2 units right, 1, 2. I'm going to continue with the same pattern for a while to make sure I have a nice set of points. Then if I connect, okay, let's look at our connection point. It's right here where two lines intersected. And our solution then, this is negative 2 and this is 2. So our solution is negative 2, 2. But I would like to check our solution to see if it satisfies the both equations. So let's check. I'm going to write the first equation first, which is x plus y is equal to 0. And I'm going to plug in for x, negative 2 plus 4y, 2, and see if we are going to get 0. And it is correct. 0 is equal to 0. So it worked for the first equation. Now let's check for the second equation. Let's check if it works also for the second equation. Our second equation is y is equal to negative 1 over 2x plus 1. I'm going to plug in 2 for y and negative 2 for x. From here, we are checking if both sides of the equation has the same value. So 2 is equal to, if I multiply or cross cancel, it is going to be 1 here plus 1. So 2 is equal to 2. So this one was also correct. So we checked our work. It works for the both equations. Great job, everyone. Let's just give us a sticker from here. And well done. And I'm done with this video. See you next time.